Hi everyone, my name is Nivedita Gouda, B.Ed second sem student of KLE Society's College of Education, Ankola. Today, I am here with a very interesting session on Chapter 6 of Standard 10, which is Triangles. Let's begin with a simple question. Is it possible to measure the height of mountains and how far the moon is away from us using a measuring tape? My answer would be yes. These kind of heights and measurements are measured on the basis of idea called idea of indirect measurements. This idea is based on the principle called principle of similarity of figures. The first one is congruent figures. Two figures are said to be congruent if all of their sides are equal and all of their angles are equal in size. Here are some examples for congruent figure. Triangle A and triangle B are congruent because all of their sides are equal in size and angle. Circle A and circle B is also congruent because both of the circles have radius of 3 cm. The next one is similar figures. Similar figures have exactly the same shape but not necessarily the same size. Two figures are similar if and only if the lengths of corresponding sides are proportional and all pairs of corresponding angles have equal measures. Here, the size doesn't matter at all. The symbol for similar figure is this. These are some examples for similar figures. Here circle A is bigger than circle B but both have same shape. Same goes with square. Square A is greater than square B but both have similar shape. In case if we compare a square with a rectangle, then they would not be a similar figures. From this we conclude that all congruent figures are similar but all similar figures aren't congruent. Now let us move on to exercise 6.1. Fill in the blanks using correct word given in the brackets. First question. All circles are dash. The answer is similar. All circles mean circles having different shape. The circles which have different shape are not congruent, so these circles are similar. Second one. All squares are dash. The answer is similar. Third question. All dash triangles are similar. The answer is equilateral because in equilateral triangles all sides are equal. But in case of isosceles triangle it is not so. Fourth question. Two polygons of same number of sides are similar if A. Their corresponding angles are dash and B. Their corresponding sides are dash. Polygons means anything, it may be hexagon, heptagon or octagon. We know that in case of similarity of figure, sides may or may not be equal but the angles should always be equal. So here A answer is equal and B answer is proportional. Here is another question. State whether the following quadrilaterals are similar or not. The answer is from the given two figures we can see that corresponding angles are different or unequal. Therefore, they are not similar. Now, let us move on to similarity of triangles. Two triangles are similar if they meet one of the following criteria. First one is AA, which means two pairs of corresponding angles are equal. SSS, three pairs of corresponding sides are proportional. SAS, two pairs of corresponding sides are proportional and corresponding angles between them are equal. The next concept is basic proportionality theorem (BPT). Basic proportionality theorem was introduced by a famous Greek mathematician Thales, hence it is also called as Thales theorem. Let us now try to prove the basic proportionality theorem statement. The theorem states that if a line is drawn parallel to one side of triangle intersecting the two other sides in distinct points, then other two sides are divided in the same ratio. Proof. Now the area of triangle APQ is equals to half into AP into QN because area of triangle is equals to half into base into height. Similarly, area of triangle PBQ is equals to half into PB into QN. Area of triangle APQ is equals to half into AQ into PN. Also, area of triangle QCP is equals to half into QC into PM, which is equation 1. Now, if we find the ratio of area of triangle APQ and triangle PBQ, we have area of triangle APQ divided by area of triangle PBQ. Half and QN get cancelled, so we get AP divided by PB. Similarly, area of triangle APQ divided by area of triangle QCP is equals to AQ by QC, which is equation 2. According to the property of triangles, the triangles drawn between the same parallel lines and on the same base have equal areas. Therefore, we can say that triangle PBQ and triangle QCP have the same area. That is, area of triangle PBQ is equals to area of triangle QCP, which is equation 3. Therefore, from the equation 1, 2 and 3, we can say that AP by PP is equals to AQ by QC. Also, triangle ABC and triangle APQ fulfill the conditions for similar triangles as stated above. Thus, we can say that triangle ABC is similar to triangle APQ. So, the BPT is hence proved. Here is a solved example on BPT. In triangle ABC, sides AB and AC are intersected by a line at D and E respectively, which is parallel to the side BC. Then prove that AD by AB is equals to AE by AC. Here it is given that DE is parallel to BC by observing the triangle. So AD by DB is equals to AE by EC, or we can interchange the ratios as DB by AD is equals to EC by AE. Now add 1 on both sides. So it becomes dB plus AD divided by AD is equals to EC plus AE divided by AE, which is AB divided by AD is equal to AC by AE. If we interchange the ratios, again we get AD by AB is equals to AE by AC. Hence, proved. Now, the another important concept is Pythagoras theorem. Statement: Pythagoras theorem states that in a right angle triangle, the square of hypotenuse is equal to the sum of square on other two sides. The sides of this triangle have been named perpendicular, base, and hypotenuse. Here, hypotenuse is the longest side and it is opposite to the angle of 90 degree. This theorem is named after a Greek mathematician called Pythagoras. Pythagoras theorem formula. Consider triangle given above, where A is perpendicular, B is base, and C is hypotenuse. So the formula will be hypotenuse square is equals to perpendicular square plus base square, which is C square is equals to A square plus B square. Example: consider a right angle triangle given below. Find the value of x. Answer: x is the side opposite to the right angle, hence it is a hypotenuse. Now, by the theorem we know hypotenuse square is always equals to base square plus perpendicular square. So x square is equals to 8 square plus 6 square. X square is equals to 8 square 64 plus 6 square 36, which is equals to 100. So x is equals to square root of 100. So the square root of 100 is 10. So from this we get the value of x as 10. Now let us prove the Pythagoras theorem. Given a right angled triangle ABC, right angled at B, to prove AC square is equals to AB square plus BC square. Construction: draw a perpendicular BD meeting AC at D. Proof: we know triangle ADB is similar to triangle ABC. Therefore, AD by AB is equals to AB by AC, which are the corresponding sides of similar triangles. Or AB square is equals to AD into AC, which is equation 1. Also, triangle BDC is similar to triangle ABC. Therefore, CD by BC is equals to BC by AC, which are the corresponding sides of similar triangles. Or BC square is equals to CD into AC, which is equation 2. Adding the equation 1 and 2, we get AB square plus BC square is equals to AD into AC plus CD into AC. Then AB square plus BC square is equals to AC is taken as common, so AC in bracket AD plus CD. Since AD plus CD is equals to AC, therefore AC square is equals to AB square plus BC square. We have now got the required answer, hence the Pythagoras theorem is proved. The application of Pythagoras theorem in real life. It is used in construction and architecture. Used to survey the steepness of the slopes of mountains or hills, to calculate the length of staircase required to reach a window, to determine heights and measurements in construction sites. By this, I would like to wind up the video. Thank you for watching.